Alright guys, welcome back to the next set of notes here. We'll be going over section 9.2 in this section, so that way you are able to see exactly what you need to do. We're actually going to be breaking this video up into two sections, so you're actually going to get one section that is on kind of getting started on how to use a scatter plot, and then the next section will be on just more applications, more practice, and that'll relate more closely to your homework assignment that I want you to do. So today is going to be just kind of getting used to it. It's not going to be a lot of in-depth material. It's just going to be getting used to knowing what you need to know about how to graph a scatter plot and use a line of best fit. So our essential question is, how can you use data to predict an event? Well, when we look at scatter plots, we will notice that when we're comparing two things, we can identify trends. This is going back to what we talked about in the last section. And today what we're going to do is we're going to be looking at certain examples of how that works given a specific scenario. So we're going to take a look at one here pretty soon involving that kind of situation. All right, so here we have a scatter plot given an example. So you've been working on a science project for 8 months. Each month you measured the length of a baby alligator. The table shows your measurements. So the table below shows the months that you've recorded, the given lengths in inches here of a baby alligator. So we've got months as X and lengths in Y. So you can see we have 8 different data points starting all the way in September all the way to April. Okay. So if we look at September here, this is our beginning point of our data. So we're starting right here, okay? And then we end all the way down in April. So our data begins at X is 0 in September, and it ends when X is 7. And then you can see the respective lengths along the table. Okay, so what we're planning on doing is using the following steps to predict the baby alligator's length next September, okay? So first thing we're going to do is we're going to graph the data in the table. So I'm going to slide the table down here. Let me just erase that. All right. And then I'll slide the screen down so we can all kind of see the positions. Okay. So what we're going to do first is we are going to graph the data in the table. So that means we're going to take all of our values and we're going to put them on the graph. So if you know, and you remember from before, X and Y's pair together to make points. Okay, so we're going to use these numbers to put them on our graph. All right, so this first one here is actually going to be our y-intercept. Okay, so it's at the point 0, 22. X always comes first, y always comes second. So what we're going to do is we're going to go over to the graph here, and if you notice there's that little kind of like zigzag mark like right here, okay, that just means that we're skipping a bunch of data without actually changing the increment in which we increase, because every line we still want to be 1, but we don't have any data below 22, if that makes sense. Okay, so don't worry about that too much. Just understand that what we're doing here, we're starting at the point 0, 22. So that's where we're going to put our first point. And then what we'll do for the rest of these here is we're just going to put them then in the exact same way on the graph that you see up in the table. Okay, so the next point is going to be 1 and 22 and a half, and then why don't you just go ahead and fill this in here with me, or you can stop and try to fill in your own and see what you get. Okay, and again, don't worry about it being exact, because it's going to be as close as we can get it as possible. It's not necessarily going to be something that you have to know right on the dot. Okay, so here is 2 and 23 and a half. We've got 325. And we got 426, 527 and a half, 628 and a half, and 729 and a half. All right, so now we should have all of our points on the graph here. Just get rid of that arrow, and then we will look at part B. So it says draw a line that you think best approximates the points. Now, if you notice, there is a pattern that these points form, okay? It's a point that is, or a form that is similar to what we talked about in the first section, that involves whether it's going to be linear, nonlinear, or neither. And in this case, it is actually linear, okay? Because it tells us to draw a line. And it's actually going to be positive linear, because as the x's increase, the y's also increase. Okay, so what we can do then is we actually have the ability to draw a line that you think best approximates those points. And I'm going to do that right here. So you can see how I drew a line that kind of goes right in the middle of all of them. It doesn't exactly hit all the points, but it goes right through almost all of them. Okay, now remember, this is best approximates. This is not exact. So if yours doesn't hit the same points that mine does, that's totally fine, as long as it's going in the middle of the data and it's appearing to be linear. Okay, now when we draw a line, the cool thing is we are able to draw or write an equation then to represent that line, because what we want is to predict the baby alligator's length next September. So if we can figure out an equation from a line that we drew, that will allow us to figure out what the heck we're trying to do. Okay, so I'm going to just give a little bit of space here so we can start. Sorry if you guys don't have a ton of space in your paper, in your notes, but we are going to start trying to find that equation. Now, when we draw lines, what do we think of when we think of lines in terms of equations? Hopefully you guys remember, but we remember slope-intercept form, which is y equals mx plus b, where m is your slope. Okay, yes, we are going back to slope here, and b is your y-intercept. So these words should be familiar to you guys. So we need to find both of those in order to write that equation, okay? And now the easy one is going to be your y-intercept, because we have a point that is actually on our line that's right on that y-intercept. Now, guys, it's important that you're picking points for your line that are on the line, not necessarily points that you want to use. Now, I chose to draw my line through that point because I knew it was going to make it easier for me. Now, not every line, and you'll notice in tomorrow's notes that not every line goes exactly through the point that you think. Okay, so it's just really important that you pick your points that are actually on the line that you drew, not on the actual data points. Then you're going to get something that's completely all over the place, and it's not going to make a ton of sense. Okay, the points that I'm going to pick though are going to be these two that I highlighted in yellow. Okay, so up in the table, those are your points 6, 28.5, and 7, 29.5. Okay, so those are my 2 points. Now what we're going to do with those 2 points, if you guys remember, when we find the slope of a line with 2 points, okay, we use y2 minus y1 over x2 minus x1. So if I write out my 2 points, I've got 6, 28.5, and 7, 29.5. All right, so if you guys remember, we'll label those out, okay, to find the slope. So here's the formula, just in case you forgot. So it's y2 minus y1 all over x2 minus x1. All right, now we always label our first coordinate as the x1, y1, and our second coordinate x2, y2. And then with that, we'll just plug in and go. So we will do 29.5 minus 28.5 all over 7 minus 6. Okay, now we just simplify. So 29.5 minus 28.5 is 1 over 1, and then 7 minus 6 is also 1, which just simplifies to 1. So we now have our slope, and we now have our y-intercept. Okay, so we now have our 2 points. So once we have m and we have b, we can now plug it into an equation then to represent the length of the alligator over time. So we're going to use 1 for our slope, so y equals 1x, or you could have just said x, plus the initial length, which is right here, and that is going to be 22. And there's your equation for your line. And that's kind of the gist of what we're trying to do here, guys. That's all we're trying to do. We're just drawing a line and writing an equation. The only thing that makes it difficult is that you're adding in additional points that you might not already know. Now, we're going to go to the modeling section here, and we're going to use the equation now to predict the baby alligator's length next September. Okay, so if we look at this here, guys, we know that in a year from the beginning, that would be 12 months. Okay, so we're going to say that x is 12. That would be the representation for next September. So all we're going to do is we're going to plug in our x value of 12, simplify it, and then that should give us what the length is. And you can see below, I do 1 times 12 plus 22, that equals 33. So that would imply that we are dealing in inches. So this is 33 inches long for that baby alligator. Okay. Now, guys, it's important that you understand that we are just simply being able to look at a graph here and figure out what exactly we need in order to write that equation. Okay. We need some sort of linear pattern. We need 2 points, and we need a y-intercept. Okay. You draw that line, then it's just like we had done everything else before. Okay. With that, we will be ending this video here, and I hope you guys made some sense of that and you could try your homework, and then I will be posting the second half of the video for you guys tomorrow. Have a good day.